Math Tutor Insights here. Welcome back to another video. Now, as you can see, I've got a blank screen. I haven't written down the topic, but in the description of this video, you might have come across. So, yes, we are going to be looking into differentiation. Now, if you are new to this channel, you can always subscribe and keep yourself notified for upcoming videos. And also, if you would like to join one of my summer programs where I will be going over AS topics and A2 topics in more detail and to help students with their transition, check the description in the link below to book a call and we can discuss more your fit for the program. So let's go straight into it. So I'm going to write the title, Differentiation. Now we're going to be covering the basics understanding what differentiation is. So it's good for A-level students that are just going to be learning this in September. And this will be good for students that are already in A-level and they just want to get a quick recap, perhaps during the summer or just whenever they feel like it. So let's get into it. So differentiation, I like to break this down into two words. Now, I'm not going to break it down using the word differentiation, but the two words I have in mind is gradient, and the second word is called differentiate. Now, these two words, once I understand what they mean and then I can combine them together, it will allow me to understand differentiation before we even tackle some questions, which is the whole point of this video. So let's go into the word gradient, which is the easiest one. So gradient, as you know, is whenever you want to work out a change in y over a change in x. So when we first learned gradient, we first covered gradient with linear equation. So if this is a linear equation, I'm going to put the form, which is y equals mx plus c. Now, each of these letters have a meaning. Now, M stands for the gradient. Now, the fact that I have a linear line, this is a straight line. So what this means is, if I was to take any point on this line, so let me just take these 3 points. The fact that I have different points on the line, but the fact that if I was to work out the gradient would be the same because the line is straight. And this is the initial function I have. So therefore, my gradient is going to be constant because any point I go across this line is a straight line, so therefore my gradient is constant as I find out my change in x over my change in y. And that's why, for example, if you have y is equal to 2x, that means if I draw this line, 2x, at any point on this line, my gradient is going to be 2, because the change in y and the change in x is constant, it's the same. But I can be at different positions on the curve. So that's what gradient is. And of course, it can be steeper. The larger it is, the steeper it is, and the lower, the smaller the number is, then the less steep it is. And of course, you can have when there's a zero gradient, and that is common when we are going to look into a different type of function. So we've looked into linear equations, and these are when you have equation of a straight line. Now you can have equations that are non-linear. Now, before I get into that, I want to touch on briefly with the word differentiate. So differentiate, and also to help you understand, this is something, an insight I like to share whenever you are learning any new word, is that sometimes we can actually apply general logic to it. So whenever you are going to differentiate something, you need to have at least two things to compare. So therefore, you can at least differentiate between the two. So what that means is, in context of a non-linear equation, if I was to draw, so example of non-linear is a quadratic, it can be a cubic. These are just two basic examples. Of course, there are many others. So if you have a function of higher polynomials with powers of 4 or 5, or if you have an exponential graph, e to the x, or you have a log or ln, these are all non-linear because if I draw, for example, a quadratic, this line is not a straight line. If I draw a cubic, and there's different types of cubic graphs, these lines are not straight lines. It's a line but going in different directions. And this is another key point which we're going to. So looking at these set of graphs, and they are non-linear. Because they're non-linear, Therefore, if I was to take any point, or if I was to take at least 2 points, because I said part of differentiating is that I want to compare. If I want to differentiate something, I need to compare at least two things. So I want to compare two different points on these graphs. So let's take this one. I'm just going to duplicate it. So let's take this graph here. Now this graph here, if I was to take any 2 points on this graph, now let's change this pen color. Now I want to take this point here, and I want to take this point here. And I could, I'll say let's take this point. So let's take 3 different points. Now, if I wanted to work out the gradient, the fact that I have different points, but these points are on different points on the line and the line is not straight, so my gradients are going to be different. And that is why I'm going to be using differentiation. Because at different points on this non-linear line, I'm going to have different gradients, and different gradients is going to result in differentiation because I'm going to differentiate between my gradients on different points on the line. So now let's actually look into this in more detail. So again, as we said, the gradient, we need to use the concept of a straight line. Now, when we have a nonlinear function, in order to draw a straight line, I'm going to draw a tangent. So tangent is something you've covered in before A level. So if I draw a line going across, this is my tangent. If I draw a tangent line, this is another tangent. I can draw another tangent line here. I can draw another point here. So let me take this point here. If I draw a tangent line, so you can see I have 4 tangent lines, and these tangent lines, they are straight lines. So now with these straight lines, I can work out the gradient at this point on the nonlinear curve. So now, to work out the gradient when I have a nonlinear line, we use something called dy over dx, and it's the same as f with an apostrophe and then x. And usually the standard notation for any function, it could be fx, or we can use y. So for example, we use y is equal to mx plus c. Now another way you can write your function is fx, so your function is in terms of x. Now to work out a gradient, we said we need to have a straight line. Now when you have a non-linear curve, your straight line, you're going to draw it by taking a point on this curve and then draw a straight line going through it. And this would allow us to work out the gradient. And as we can see, because these straight lines, they are in different directions, they're going to have different gradients. And again, that's why it is differentiation, because we are differentiating between different gradients at different points in the line. So let's look at this first point. So this point here is going to have a positive gradient because this line is going up. And as you can see from the graph where we're starting from, I put S and F, where I'm starting from, the graph is increasing, so it's going up. So the gradient is increasing. Now, it's going to reach a point where it does not increase any higher. So there will be a point when it will be 0. And now the word for this is called a stationary point. So when something is stationary, as we know, generally speaking, when something is stationary, something is still, it's not moving. So therefore, if it's not moving, it's still, the gradient is going to be 0. Of course, we'll go over this in another video. And this is when, especially for those not learning A level, this is one of the ways we can dive into more detail with differentiation. And sometimes you'll be asked to learn how to solve the stationary points and then also describe the type of stationary points, which we will cover in another video. So again now, let's say it's reached this highest point, and then after that, it's going to go back down. So now it's decreasing. So you can see now, this tangent line, if I took this second point, this is 1, and I label this is 2, the tangent line is now in the opposite direction to the first one we had. So this straight line is going down, so it has a negative gradient. And then you can see now it's decreasing until it can't go down any further, and then it reaches a point when the gradient is 0, it's stationary, and then after that, it goes back up. And then this gradient here, this point, this straight line, tells us that the gradient is going to be positive. And then it's going to keep going up and up and up. So for this type of function, which is a cubic function, which has a x to the power of 3, and you have other terms as well, bx squared plus cx plus d. This is just the general form. This is how this graph would behave. Now, we have only looked at differentiation when we are only focusing on x and y, the change in x and the change in y. Now, we can also learn this concept of differentiation in other types of topics, and this is when it becomes more applied. So this can come across when we are looking into differential equations, because differential equations now, it involves looking at a rate of change. And a rate of change is basically when you have the gradient between two variables and they are changing over time. So this rate of change is basically telling us the gradient between two variables. Now we have looked at two variables when you're comparing x and y in a function, but in an actual word problem or in an applied scenario, we could, for example, talk about the change in volume with time. So if you are measuring water, if you have a tank and water is coming out, or you can say water is pouring in, let's say you're pouring water in. Now the volume of this tank is going to change with time. So therefore, my differential equation is going to start with a differential, which is V for volume and with time. So it's going to be increasing. So I'm going to have an equation which is describing my gradient and the rate of change of my volume with time. And again, I won't go too much into detail, but this is essentially why we use differentiation and how it could be used in other areas. And if I was to mention one thing to get out of this video is to understand that differentiation, it's used whenever we have nonlinear lines or nonlinear curve, and you want to work out the gradient at different points on a line that is not straight. Because when you have a different gradient, those different gradients, when you compare them between the two, you're going to be differentiating, and that's how we come across differentiation. So I hope this was beneficial for you, and look out for the next videos where we will probably look into some questions where we'll be tackling how to differentiate actual functions, and also looking into some differential equations coming up soon, and learning as well different differentiation techniques, which will be very, very important. So with that being said, if you would like to also receive a guide on all of the different differentiation techniques, and I'll be comparing the differences between the two, how to spot when to use each one, etc. So this can save you time in your revision. I'm happy to share that with you. So if you would like to receive that copy, please make a comment underneath this video, and I'll be happy to provide it for you. So once again, I'll see you on the next one.